In this video, I'll be going over how to simply plug it in, which is my favorite technique. That's what she said. So what do I mean by that? Take, for example, question 8. If a over b is equal to 2, what is the value of 4b over a? Now, at first glance, you might know how to do the math for this, or you might not. But the easiest thing to do is actually going to sound a little crazy. Let's just guess two numbers. Let's choose a number for a and choose a number for b that makes this statement over here true. So what do I mean? Like, say, for example, I said a is equal to 2 and b is equal to 1. Well, I don't know what a and b are, but based on the information they gave us, this is certainly a possibility. A over b is equal to 2, well, 2 divided by 1 is equal to 2. So a is equal to 2 and b is equal to 1 makes this statement true. They want to know what is the value of 4b over a. Well, we said what a and b are, so let's just be consistent with that and plug it into 4b over a and see what we get. Well, 4 times b is just going to be 4 times 1 because we said b is equal to 1. Divided by a, well, we said a is equal to 2. 4 times 1 divided by 2 is going to be 4 over 2, which is equal to 2. Guess what? That's your final answer, C. 4b over a has to equal 2. Now, you might be saying to yourself, yeah, but I knew it was going to equal 2, and that's why I chose 2 and 1, but other numbers might not work. But actually, no. Any number that you choose that makes a over b equal to 2 true would have to make 4b over a equal to 2. And if you don't believe me, try it out for yourself. Try 4 and 2, try 10 and 5, try 1,500,000, whatever. And that makes sense because if 4b over a can equal different things, then how would this question make sense at all? It has to be that no matter what you plug in that makes the first statement true would have to make the second statement the same thing no matter which numbers you try. You can see how much easier doing a question like this is than actually doing the math. If you look at it and they say something like a over b is equal to 2, just go, okay, let's just choose a number for a and b and roll with it and see what we get. And it's such a quicker, easier, much less stressful way to get the question right every time in like 10 seconds. All right, let's move on to question 9. Question 9 is 3x plus 4y equals negative 23 and 2y minus x equals negative 19. So this is a system of equations. Now you can solve this the correct way you're supposed to solve a system of equations, but maybe you don't want to or you don't know how. Another possibility of what you can do is just plug in each point to each of these equations, a, b, c, and d. One of these points is going to make both of the equations correct, and that's going to be your final answer. So this is another way to get the question right instead of just solving a system of equations. So say, for example, let's try a. A says the point is negative 5, and remember that the first point is x, so negative 5 is going to be x, negative 2 is going to be y. So let's plug this into the equations and see if it works. Well, 3 times x, we said, is negative 5, so 3 times x is going to be negative 15. 4y, we said y is negative 2. 4 times negative 2 is negative 8. So we get negative 8. Negative 15 plus a negative 8 is negative 15 minus 8 equals negative 23. So that works. So this is looking good. But we have to plug it into both equations. If we plug in the second one, 2y, y is negative 2. So that's going to be negative 4. Now remember, minus x, since x is negative 5, minus a negative 5 is the same thing as plus 5. Negative 4 plus 5 does not equal negative 19. It equals 1. So choice A does not work because it does not work in both equations. But let's say we try choice B. B is saying the x is 3 and y is negative 8. Well, 3 times 3 is 9. 4 times negative 8 is going to be negative 32. 9 plus a negative 32, sorry, I can't write with this mouse. 9 plus a negative 32 is going to equal negative 23. So the first statement works. The second statement, 2y is going to be negative 16 because y is negative 8. 2 times negative 8 is negative 16. Minus 3. Negative 16 minus 3 does equal negative 19. So B works in both of them. So B is going to be your final answer. Now, one thing to note when doing this plug-in method where you do A, then B, then C, then D, is if you get unlucky, it could really suck. Because like if it's all the way the fourth choice that I plug in, that's going to be a lot of work that maybe would have been easier the other way. But even so, this is definitely a valid option of just plugging in the points into the two equations and seeing which one works for both. All right, now let's move on to question 14. Question 14 is if 3x minus y is equal to 12, what is the value of 8 to the x over 2 to the y? Now, my approach for solving a question like this, because this seems like a very hard question, again, I wouldn't know at first glance how to solve this the correct way. Well, let's do what we did in the first time in our first question where we just chose two random numbers. Let's choose a number for x and choose a number for y that makes this first statement over here, 3x minus y equal to 12, true. Well, I definitely want to use easy numbers, and I would love to use like a 0 in it. So let's say x is equal to 4. X is equal to 4. Well, that would make this over here 12 minus a 0. If I said y is equal to 0, then that's true. 3x minus y is going to be 12 minus 0, which is equal to 12. So that works. So we said x is equal to 4 and y is equal to 0. Now let's plug it into a to the x over 2 to the y. Well, a to the x, we said x is 4, so it's going to be 8 to the 4. 2 to the y is going to be 2 to the 0. Now, if you know a little bit about exponents, you'll know that any number to the 0 is equal to 1. Anything. So 2 to the 0 is just going to equal 1. If you're divided by 1, you're not changing anything, so we can ignore it. So 8 to the x over 2 to the y, if we said x is equal to 4 and y is equal to 0, is just going to equal 8 to the 4th power. Now, unfortunately, looking at your 4 choices, I don't see an 8 to the 4th power. But I know 8 to the 4th power is not 4 to the 4th power, because we have the same exponent but a different base. And I know 8 to the 4th isn't the same thing as 8 to the 2nd, because I'm taking the same number and changing to a different exponent. So I know that B and C both are not correct. So is it that the value cannot be determined from the information given? Or is it that it's 2 to the 12th? Well, this you might actually have to work around with a little bit. If you were able to break this up 8 to the 4th and realize that 8 is really 2 to the 3rd, then you'd realize that it's 2 to the 3rd to the 4th. And when you raise an exponent to another exponent, then it's the same thing as multiplying two exponents. So 3 to the 4th would be 3 times 4 is 12, which would equal 2 to the 12, which is a. But maybe you didn't know how to do those exponents. But let's say we chose two different numbers for x and y. Let's say we said x is 0, which would mean we would have to say y is negative 12, because 0 minus the negative 12 would equal 12. So we're going to say that x is equal to 0, and y is equal to negative 12. Well, I said anything to the 0 is equal to 1. So 8 to the 0 is going to be 1. And we're going to have over 2 to the y. We said y is negative 12. So we're going to have 2 to the negative 12. Now, if you guys know what negative exponents means, you might think that it means that your answer is going to be negative or something. What it actually means is it's the same thing as the positive exponent, but you flip the fraction. So 1 over 2 to the negative 12 is really, you flip it, so 2 to the negative 12 is going to be on the top, and then you make it positive, and it's going to equal 2 to the 12. So both of those are ways that you could figure out. Either take 8 to the 4th and break it down, or if you chose two different numbers where you made x 0 instead of y 0, you would see it's 1 over 2 to the negative 12. You flip it, and you'll get 2 to the 12th. All right, let's go all the way to the math with the calculator section and go to question 8. Question 8. For what value of n is the absolute value of n minus 1 plus 1 equal to 0? Now, for those of you who are not familiar with absolute value bars, all this means is that if it's a negative number, you make it positive. So if inside your absolute value bars you have 0 or any positive number, the absolute value bars do nothing. If it's a negative number, it's positive. So negative 7 would be equal to 7. Negative a billion would be equal to a billion. 0 is still equal to 0. 8 is still equal to 8. That's what absolute values are. So for what value of n is n minus 1, the absolute value of that, plus 1 equal to 0? Well, we have a few choices over here. Let's plug them in. Let's plug 0 in. 0 minus 1 is equal to negative 1. But the absolute value of that is equal to 1. So n minus 1 is equal to 1. Plus 1, well, 1 plus 1 is equal to 2. That's not equal to 0. So we can rule out choice A. Choice A did not work. Similarly, if we plugged in point B, if we plugged in choice B, which is 1, you'd get the absolute value of 1 minus 1. Well, 1 minus 1 is just 0, and absolute value doesn't change that. Plus 1 is going to equal 1. Well, 1 is not equal to 0, so choice B does not work either. So it's not choice B, it's not choice A. Again, if we tried choice C, I'm just going to say it because I'm really having difficulty writing with this. If C is 2, well, 2 minus 1 is 1, plus 1, again, is equal to 2, not 0. So A, B, and C did not work. Now, it's true that you might not know that there's no value of n because we only plugged in 3 choices, but one of these 4 choices is true. And if it's not A, and it's not B, and it's not C, then it's D. There's no such value of n. But one thing I want to point out over here is you actually don't even have to revert to guess and check. There's an even easier way to do this by using logic. The absolute value of anything is always going to be positive or 0. So at the very, very least, this number is going to be 0. or maybe it's positive. Any number that's 0 or above that you're going to add 1 to, how are you ever going to equal to 0? That's not really possible. You need the absolute value of this thing to equal -1. That way, when you add 1, it equals 0. But the absolute value is never going to be -1. So by using logic also, you can see that the answer is D. Let's move on to question 11. Question 11. Which of the following numbers is not a solution of the inequality 3x minus 5? This symbol means is greater than or equal to 4x minus 3. So again, what we're going to do here is just, instead of solving the inequality, which you could do, I'm just going to plug in A, B, C, and D, and which one is not a solution. Remember that big not over here. Not a solution. So let's see if I plug in -1, what I would get. 3 times -1 is -3. Minus 5 is -3 minus 5 is equal to -8. Or, you know what, I'll just write -3 minus 5 for now. And I want to see, is that greater than or equal to 4 times -1 is -4. -4 minus 3 is going to be -7. So in other words, when I plugged in -1 as x, I got -8 is greater than or equal to -7. Now, you might say, yeah, 8 is greater than 7, so this works. But actually, if you think about your number line, it's going to be -8 and then -7. And then you get down to like 0, etc. -8 is actually less than -7, not greater than or equal to it, which is why A is true. And if you plug in B, C, and D, you'd see that those numbers actually make the inequality correct. But A made it incorrect, which is why that is the right answer. Finally, let's move on and try question 18. Question 18. Y is less than -x plus A, and y is greater than x plus B. Okay, that seems a little weird. There's a lot of letters over there. Let's read what they say. In the xy plane, if 0, 0, which is a point, is a solution to the system of inequalities above, which of the following relationships between A and B must be true? Like, wow, this looks like a lot to deal with. I wouldn't even know how to do anything besides plug it in here. But they gave us a point to plug in. They told us 0, 0 works. Now, this is so complicated over here. I want to write this in ways I can understand even what's going on before I even look at the choices. Well, 0, 0 means the x and the y are both zeros. So this top equation is going to be 0 is less than -0 is still 0. So it's just going to be 0 is less than 0 plus A. Well, I don't need 0 plus A. So in other words, 0 is just going to be less than A. Suddenly the bottom equation is going to be 0 is greater than 0 plus B. 0 plus B is, again, just B. So 0 is greater than B. Okay, now that I plugged in the point 0, 0 into the information they gave us, this looks like a lot more sense. 0 is less than A, and 0 is greater than B. So again, if you want to understand a little bit what's going on, 0 is less than a number. So what could A be? Well, let's say A is 1. 0 is less than 1. That works. 0 is greater than B. So what could the number B be? Well, let's say B is equal to -1. So this works. A is 1 and B is -1 works. So which of these has to be true no matter what? Well, let's start with choice D. A is equal to -B. Well, that is true based on the information that I just gave. So this might look a little tricky. But remember, B could also be equal to -2 or maybe -3. And 0 is less than A. A can be 17. So it's not actually true that A has to equal -B. But it's tricky because by plugging in a 1 and -1, you might think it is. The absolute value of A has to be greater than the absolute value of B. Again, that's not true because let's say the absolute value of B, let's say I did -1,000 for B, whatever. The absolute value of that is going to be 1,000, and A we know can just be like 1 or whatever. So B, the absolute value of B does not have to be less than the absolute value of A. B is greater than A. Well, that's for sure not true because B has to be negative and A has to be positive. Oh, but look at choice A. A is greater than B. Out of all of the numbers you can choose, A has to be positive and B has to be negative. Look at the numbers I wrote over here. So you know that A has to be true. A has to be greater than B based on plugging in 0, 0 into the two equations, trying out some values of what could be what you see, you know that A always has to be greater than B. So this has been plugging in choices or your own guesses into the information they give you and seeing what works. Hopefully this is going to be a quick, easy thing for you to learn, and hopefully it's helpful.